So we're always hearing about AI getting bigger, faster, more powerful. But what if the real game changer isn't about getting bigger, but about getting smarter, like actually thinking differently? Today, we're going to look at a radical new path for AI that could literally change everything. Think about it. Right now, the AI we use every day is amazing at one thing, predicting the next word in a sentence. But what if it could go deeper? What if an AI could actually get the idea, the concept of a dog running, instead of just seeing the words dog and running? This one question is creating a huge fork in the road for the future of AI. And to really get why this is such a big deal, we kind of have to understand the path we're on right now. So let's pop the hood for a second on the AI that, is basically everywhere these days. I mean, you know the drill. You type something in and the AI just starts typing. One word after another. It's almost like this chain reaction, right? Each new word is just the most statistically likely one to follow all the ones that came before it. Okay, so there's a fancy term for this, autoregressive. But all it really means is that the AI is this incredible prediction engine. Its whole job is to ask over and over, okay, based on everything so far, what word comes next? And look, it's super powerful, no doubt. But, and this is a big but, it's also got some serious limitations. And those limitations are exactly what's making some of the biggest names in AI stop and ask a pretty tough question. Is just guessing the next word really the same thing as understanding? This whole idea is being pushed by folks like AI pioneer Yann, and it's a huge critique of the current way of doing things. He's basically saying, hey, look, humans don't think in words. We build a model of the world in our heads, and language is just the tool we use to talk about it. So that brings us to the big question, right? Can we actually build an AI that learns more like us? One that watches the world, gets the concepts, and predicts what might happen next in a more abstract way, instead of just playing, what's the next word? Well, the answer might just be yes, and it's coming from a really cool new approach from Meta AI. It's called the Joint Embedding Predictive Architecture, or let's just call it JEPA. And trust me, this is a totally different way of thinking about how AI learns. Okay, so here's the massive change. Forget predicting the next word. Instead of guessing that running comes after dog, JEPA's entire mission is to build an abstract idea of what's going on. It's not memorizing the description, it's learning the meaning behind it. This is a perfect way to see the difference. Look on the left, you've got token space. That's where today's models live. To them, dog is running and puppy is playing are just totally different strings of text. But now, look at the right. This is semantic space, JEPA's world. It looks right past the specific words and sees the core concept, a young dog doing something active. It gets that they mean basically the same thing. That is a huge leap. Okay, Siri is great, but what does this actually look like when the rubber hits the road? Well, let's meet the model that's making it all happen, VL-JEPA. It was built from the ground up to learn in this brand new way. All right, I know what you're thinking. This diagram looks complicated. But hang on, don't get lost in the boxes and arrows just yet. The main idea is actually pretty simple. This whole machine is designed to do one thing, take in all the messiness of the world, images, text, you name it, and boil it down to the essential meaning. And we're going to break down exactly how it pulls that off. All right, let's break this down. Step 1, the X encoder looks at an image or a video. Simple enough. Step 2, the predictor takes that visual info plus a question like, what's going on here, and it makes a guess. But here's the key. It doesn't guess with words, it guesses with an abstract meaning. Now, step 3, the Y encoder looks at the real text answer and does the same thing, turns it into a target meaning. The entire goal of the training is just to make the predictor's guess match that target meaning. And that last part, the Y decoder, that's just a little translator at the very end to turn that final meaning back into English so we can read it. So yeah, the theory sounds amazing, but does it actually work? Does it perform any better? Well, to figure that out, Meta set up a classic head-to-head battle, JEPA versus a traditional next token model. And wow, the results are pretty dramatic. We're talking a controlled experiment here. Same data, same amount of training. VL-JEPA, that blue line, just consistently crushes the traditional model in red. And look at that. The longer they train, the bigger that gap gets. This thing isn't just better, it's a way more efficient learner. But wait, it gets even crazier. It's not just that it's better, it's doing more with less. The VL-JEPA model that got these amazing results, it did it with half the number of trainable parameters. Yeah, 50%, that's a massive reduction. And what that really means is that it's learning more efficiently. It's learning the concepts, not just memorizing patterns. That means faster training, it costs less to run, and it opens up the possibility of putting really powerful AI on, your phone or smaller devices. It's a huge, huge win for efficiency. And the smarts just keep coming. Imagine you're watching a live video feed. A regular AI would have to be constantly describing everything, right? The car is driving, the car is still driving, the car is still driving. It's exhausting. But because VL-JEPA gets the meaning, it can just chill and watch. And it only speaks up when the meaning actually changes, like when the car turns a corner. They call this selective decoding. And the result of that? It needs to do almost 3 times less work when analyzing a video. And it doesn't miss anything. It gets the same performance. For real-world stuff, like analyzing security footage or self-driving cars, that is a massive, massive gain. Okay, so let's zoom out for a second. What does all this actually mean? Because this isn't really about just one cool new model. This is potentially a blueprint for a whole new way of building AI. Think of it like this. The JEPA system becomes the world model. It's like the brain, the part that actually understands how things work, sees the connections, and predicts what's next. And the large language models that we all know and love, they become the language layer. They're like the mouth. Their job isn't to understand the world. Their job is to be the world's best communicator, taking all those deep insights from the brain and putting them into words we can all get. So this isn't about the end of LLMs. Not at all. It's about giving them a super smart new partner. We're moving from an AI that's just a master of words to an AI that's a master of the world that just happens to have a brilliant translator. And that really leaves us with a mind-blowing final thought. For so long, we've been obsessed with predicting the next word. But what happens when we build an AI that can truly understand and predict the next anything? If it can model our actual world, the predictions it could make in science, medicine, robotics, it's almost impossible to imagine how far that could take us.